Good day everyone. To give you a flavour of the cooperation inherent in the Southwest Hub project, the photo on the right shows GSWA staff, researchers and contractors collaboratively assessing the cores from the Harvey wells laid out at the GSWA core facility at Carlisle, which is located here in Perth. I acknowledge Dominic Van Gent and Sandeep Sharma as much of this presentation originated from them. We are pleased to have worked closely with a number of government agencies, researchers and the private sector. The funding for the project was from both the Commonwealth and state. I will discuss the history of the project, followed by detail on the potential reservoir or seal intervals and the concept of migration-assisted trapping, and finish with an overview of available reports and data. The Southwest Hub CCS research project is in the southwest of Western Australia, within the Shire of Harvey, approximately 13 kilometres northwest of the town of Harvey. The Southwest Hub project area is midway between Kwinana and Collie, where a lot of CO2 emitting industries exist. As at 2018, an estimated 25 million tonnes of industrial CO2 is emitted in this region per year. Geologically, it is a unique site within the southern Perth Basin. The Southwest Hub area of operation is located on the structurally high Harvey Ridge, near Lake Preston within the Mandurah Terrace. The terrace is bounded to the west by the southern extension of the Ballymena Fault system, and to the east by the Darling Fault. The Mandurah Terrace contains around 11-kilometre thick succession of sedimentary rocks. The objective of the Southwest Hub project is to enable major industry to make commercial decisions on carbon capture and storage technology for future projects. DMIRS facilitated the project to obtain pre-competitive geological and geophysical data and establish research to reduce the uncertainty around the suitability of the site for future CO2 sequestration. As previously described by Sharma et al. In 2017, investigation of the area was undertaken between 1998 and 2007, and the project site was identified in 2010 after several regional studies highlighted the Harvey Ridge as prospective for CO2 sequestration. In 2011, the Southwest Hub was designated an Australian flagship project and subsequently received funding from the Federal Government's Department of Industry, Innovation and Science, the West Australian State Government and Industry. The favourable geology and central position between the Collie coalfields to the south and the Kwinana industrial hub to the north further cemented the benefits of the project's location. Deep petroleum exploration wells previously drilled in the vicinity proved the existence of a thick reservoir quality sandstone formation, the Triassic age Lesueur Sandstone, and its member units the Wonnerup and the Wonnerup Members. The Lesueur Sandstone, a saline aquifer, is nearer the surface here compared to areas to the south and north. The stratigraphic column on the left shows the full Mesozoic stratigraphy of the southern Perth Basin, and the column on the right shows the stratigraphy in the area of the Southwest Hub project, where almost all the Jurassic and Cretaceous is eroded, including, importantly for this project, the Jurassic Yarragadee Formation, which is a freshwater aquifer. Operations on site commenced in 2010 with acquisition of a 110-kilometre 2D seismic survey, followed by drilling in 2012 of the deep Harvey 1 well to a total depth of 2,945 metres. A 3D seismic survey was acquired in 2013. Then, 3 medium-depth wells were drilled in 2015. With successive large volumes of new data, 3D static and dynamic models were updated several times, with the final version completed in 2018, the year the federal government funding finished. Over 2 kilometres of core was acquired from the 4 wells, and, combined with a comprehensive set of wireline logs, provided an excellent data set for reservoir, pressure, flow and geomechanical studies. The Lesueur Sandstone was deposited in the Late Triassic in a fluvial environment at the time that the basin was undergoing a phase of thermal subsidence. The lower and thickest member of the Lesueur Sandstone is the Wonnerup Member. In Harvey 1, the Wonnerup is just over 1,500 metres thick and is generally a massive coarse-grained sandstone with favourable porosity and permeability for CO2 sequestration. Harvey 1 is the only Harvey well that penetrates the full thickness of the Wonnerup Member. The overlying Geological member is dominated by paleosols, which equate to less favourable reservoir properties. Regional correlation of the Lesueur Sandstone is difficult because of the non-marine, laterally variable nature of the strata and paucity of paleontological control. The 4 Harvey wells are aerially spread across the site to test for variations in reservoir quality. A broad correlation between the wells is possible. The wells considered in the best locations for CO2 injection are Harvey 1 and 3, where the sandstones of the Wonnerup Member are at a shallower depth than Harvey 4, and improved reservoir quality was encountered there. There is no structural trapping configuration, as can be seen on the depth map of the top of the Wonnerup Member. The clean homogeneous sandstone of the Wonnerup Member is interpreted by CSIRO in 2018 to be deposited in a high energy, mainly braided fluvial to shallow marine environment and is around 1,500 metres thick in Harvey 1. This well is the only southwest hub well that intersects the full thickness of the Wonnerup Member, and this is the target injection reservoir. The sandstones are both massive and well bedded, with only very minor fine-grained intervals. The grains are medium to coarse, down to around 2,400 metres, below which they become finer. The mineralogy is dominated by quartz, with an average of 75%, followed by average 8% of K-feldspar and a similar amount of kaolinite. The petrographic report states that the sequence is dominated by poorly sorted light green clay matrix supported arkose, feldspathic arenite, diamictite, gritstone and microconglomerates. Angular fragmental texture dominate, although some samples contain rounded to semi-rounded quartz grains. CSIRO clearly demonstrate a strong facies control on the porosity and permeability. The high-energy channel fill and bar forms have the best porosity and permeability, which are the red and orange points in this plot, whereas the overbank or swampy deposits and crevasse splays have the worst reservoir quality, the grey points. Overprinting this facies control is the depth and temperature related influence causing mechanical compaction and increased diagenesis with depth. The petrophysical evaluation by Walker in 2017 interprets the Wonnerup Member to have 100% net porous reservoir, and he identifies high gamma ray layers in the sandstone which are detrital radioactive minerals concentrated in the base of channels. One objective of the Harvey 2, 3 and 4 wells was to obtain core in the Eneaba Formation and the Geological member of the Lesueur Sandstone to characterise the properties of the strata predicted then to provide containment or sealing potential. The Geological member depositional environment is interpreted as floodplain paleosols. In Harvey 2, 3, 3A and 4, the paleosols are identified by the presence of distinct features including PEDs, concretions, root traces, shrink and swell structures including slicken sides and clastic sand dikes and mottled textures. Colour is widely variable, with uniform colour in parts, but more commonly mottled combinations of red, green, purple, ochre, brown, white, and occasionally grey. The special core analysis results from the mudstone-rich samples indicate these paleosol horizons could act as baffles to CO2 flow. The wide range of porosity and permeability in the Geological member relates to more varied lithofacies present in the formation, silt, clay, mud, and sandridge, compared to the Wonnerup Member, which is dominantly sandridge. The measured porosity for the Wonnerup Member sandstones in Harvey 3 range from 5.8 to 29.7%. Total clay content in the claystone samples range from 59 to 73%. The Southwest Hub Geology does not contain any traditional top seal lithology. The storage concept of the Southwest Hub project is containment of the injected CO2 without a traditional structural trap and seal. Modelling predicts that approximately 45% of the CO2 is residually trapped, and about 55% is contained due to solubility trapping. The latest seismic interpretation over the project area contains 56 fault segments. The structure is a tilted fault block with no traditional structural trapping configuration and consists of a major north-northwest, south-southeast trending fault to the east with a series of on-echelon sub-parallel faults in the downthrown segment of the main fault. Geomechanics work confirmed that the faults were not likely to be reactivated, but highlighted the lack of information on rock strength and formation stress data, so new samples and tests would be required and should be considered as a part of any future acquisition campaign. Subsequently, all the well and seismic data was pulled together into 3D static and dynamic models to test the performance factors of capacity, injectivity and containment. The final model was undertaken by Odin Reservoir Consultants. The decision criteria that the modelling addressed was that the site can accept injection rates of 800,000 tonnes per annum of CO2 over 30 years, and the plume will remain contained for at least 1,000 years. These amounts are standard volumes from a power station. This criteria had to be met by 9 wells or less to ensure commercial viability. The results from the modelling were very encouraging, with the defined volumes and rates of injectivity could be achieved with just 3 wells and the plume to remain contained within the storage complex. Dynamic modelling of the CO2 sequestration process in the Harvey area was conducted in 2 ways. Black oil modelling, a simplified description of the physics of the fluids based on simple interpolation of PVT properties as a function of pressure. And secondly, compositional model, using a compositional approach based on a thermodynamically consistent model such as a cubic equation of state. The reference case for the final model was run as a black oil model. The top image shows the plan view and the bottom image is a cross-section through the modelled plume. In this case, the CO2 plume remains in the area of interest and does not migrate out of the Wonnerup Member. There is little change to the plume after about 600 years after injection ceases. The key risk is that the CO2 plume breaks out of the area of interest or rises to a depth shallower than 800 metres. Based on worldwide average geothermal and hydrostatic pressure conditions, the CO2 critical point where the liquid turns to gas is approximately 800 metres. 14 different models of the Harvey area were constructed to investigate the effects of the reservoir uncertainties on containment failure and the location of the CO2 plume. The intent of the uncertainty modelling is to break the model and identify the mechanism or subsurface parameters that are responsible for the failure. The results on the left show the height of the plume in all modelled cases remains deeper than 800 metres, which is highlighted in red. The scenarios where the plume entered the Wonnerup formation are coloured blue. The model results where plume containment remains in the Wonnerup are shown as green. Aerially, all of the injected CO2 remains in the area of interest, as seen in the map on the right-hand side. The main factors controlling CO2 plume migration are the solubility of CO2 in brine and The combination of the transmissibility of fluids across the faults and high vertical permeability fracture zones close to the faults. The modelling shows that the Lesueur Sandstone can store up to 3 million tonnes of CO2 per annum. Most of the scenario testing was based on injecting 800,000 tonnes per annum of CO2. There is no point in doing more work on the data we already have because we need the next level of information from the deep part of the Wonnerup Member, which would require drilling of Harvey 5. The status of the 4 Harvey wells is as follows. Harvey 1 and 4 have been plugged and abandoned and the sites rehabilitated. Harvey 2 is currently being utilised by CSIRO as part of their in situ lab. Harvey 3 is plugged and decommissioned. Curtin University have fibre optic cables cemented into the wellbore. All modelling has been completed and utilised all available data. Recently, the Geological Survey of Western Australia released the Harvey 1, 2, 3 and 4 digital core atlases. The atlases contain high-logger photos of the Harvey cores with interactive display of analysis results at icons located on the core photos. These products can be downloaded for free from the online WAPIMS database. We are very open with our information, which is all publicly available. Details can be found on any of these websites. Acknowledgement of the many people whose work I have presented here today. Thank you very much.